Hello, today we are going to go over the assignment number 5, and that is our LAN, calculating LAN, when it will be, our latitude by LAN, and then our latitude by Polaris, and then a few sunrise, sunset, twilight questions. So we're going to be working a lot with time. We're only using the Nautical Almanac today. These are the shortcut versions, so we don't need the Pub 229. So let's get started with number 1. Okay, so number 1 told us we are looking for LAN, what time LAN will be on May 23rd. Our 12 o'clock DR was 4750 north and 12534.5 west. So for the 23rd, we are going to find in the Nautical Almanac when the meridian passage would be. So our meridian passage, and what is our central meridian are our two questions here. So our meridian passage for May 23rd is going to be down at the bottom, and it's going to be at 11:57. So that's meridian passage. And that is passing at the central meridian at 11:57. So the central meridian for zone description plus 8 is going to be 120 degrees. So we need to figure out where we are in relation to it and how that's affecting when it will pass our meridian. So if we have 120 as our central meridian, and we are at 125, 34.5, the sun is going to pass the central meridian and then pass our meridian. So we need to figure out what the DLO is and then convert that to time. So 125, 34.5 minus 120 gives us a DLO of 5, 34.5. And then we are going to convert to arc to time, that 534.5. So that is in the back of the almanac. So for 5 degrees, we have 20 minutes. So I'm going to write in 20. And then we're looking for 34.5. So on our minute section, we look for 34.5 is going to be 2 minutes and 18 seconds. So 2 minutes, 18 seconds. So we have a total time difference of 22 minutes and 18 seconds. So if the sun passed our central meridian at 11:57, when will it pass our meridian? Do we add or subtract? We're going to add. So 11:57 plus 22 gives us 12:19. So our LAN is going to happen at 12:19. Okay, number 2, April 2nd, our DR, 41.6 north, 07050.75 west, and we have a zone description of +5. So our central meridian is going to be so our central meridian is going to be 75 degrees west. That is 5 times 15. So we just times our zone description by 15 to get our central meridian. And then our meridian passage on April 2nd. So we're at April 2nd, down at the bottom. Meridian passage is going to be at 12:03. So if meridian passage happens on the central meridian and we are at 07050.75, it is going to happen before it passes our meridian. So, or it's going to happen to us before it passes the central meridian. So we need to find the DLO and convert that to time. So we will 0.75 degrees minus 0.50.75 gives us our DLO. Our DLO is going to be 4 degrees 09.25 minutes. And now we need to convert that to time. So we go to the back of the almanac on our arc to time conversion, and we had 4 degrees, so that would be 16 minutes. And then we had 09.25. So 09.25 is going to give us 37 seconds. So our total time difference will be 16:37. We'll call it 16 minutes. So if it passes our central meridian at 12:03, when is it going to pass our meridian? It's going to happen before. So we're going to subtract that 16 minutes. So 12:03 minus 16 gives us 47. 12:47. And you're subtracting a little bit of seconds, so I might call it 12:46, but we'll say our LAN is at 12:47. Okay, so number 3, we have June 21st, a zone description this time of -8. So we're going to be in the Eastern Hemisphere. And so our first step is to figure out when the meridian passage would be and where that meridian passage is. And that's on our central meridian. So our central meridian is at -8. So that's going to be 120 degrees east. Our meridian passage is going to be in the almanac. So this is June 21st, down at the bottom. June 21st, our meridian passage is 12:02. So if we are Our central meridian is 120 east, and we are at 114.45. We are going to be over here at 114.45. So we need to figure out what our DLO is. That's difference in longitude. And then convert that so we can see our arc to time. So we have 120 degrees minus. We get a DLO of 5 degrees, 15.5 minutes. So now we need to convert that to time. That's in the back of the almanac. We have 5 degrees, gives us 20 minutes. And then the 15.5 gives us 1 minute and 2 seconds. So we have a time difference of 21 minutes. So our meridian passage on the central meridian was at 12:02. When is it going to hit our location? The sun is moving west, so we are going to add our 21 minutes. So we have 12:02 plus 21 gives us an LAN of 12:23. Okay, for our number 4, we're on September 12th. We have a zone description of -1 and our DR position. So to figure out our central meridian, our zone description is -1, so our central meridian would be 15 degrees east. And then when would our meridian passage be? We're going to go to September 12th and find our meridian passage at 11:56. So if we draw out our situation, we have 15 degrees east, and then our longitude of 01955. So that the sun will pass us before it gets to the central meridian. So we need to figure out the DLO to figure out the time difference on when those things are happening. So our 01955 minus 015 gives us a DLO of 4 degrees, 55 minutes. We need to convert that to time. So our 4 degrees is going to be 16 minutes. 55 seconds, or 55 minutes is going to be 55 even is 3 minutes and 40 seconds. So we have a total time of, we'll call it 20 minutes. 19, we're rounding up to 20 minutes for our time difference. So if it passes 15 degrees east at 11:56, we have a 20-minute time difference between when it passes us. And it's going to pass us first as the sun moves west. So we are going to subtract that 11:56 minus 20 degrees gives us 11:36 as our LAN. That's our LAN. Okay, number 5, we are on December 3rd. Zone description is +7, and we have our DR. So our central meridian for where we are is going to be 105 degrees west. That's 7 times 15. And then the meridian passage for December 3rd is going to be in our almanac. We're at December 3rd. Down at the bottom, we have a meridian passage of 11:50. So now I'm going to draw out where we will be in relationship to our meridian passage. So we have 105 west, and then we have ourselves at 112:15. So the sun will pass the central meridian before it passes us, and we need to figure out by how much. So what is our DLO? We have a difference here of 7 degrees, 15 minutes for our DLO. Now we need to convert that to time. Back of the almanac, using the conversion arc to time, we have 7 degrees. That's going to be 28 minutes. And then 15 minutes is going to equal 1 minute. So we have a total of 29-minute time difference. Now, if the sun passes the central meridian at 11:50, and our time difference is going to be 29 minutes, the sun will pass us later. So we are going to add that 29. So we get a LAN of 12:19. And that's number 5. Okay, so for the next section of homework, we're figuring out what our latitude is by LAN. So we're using the first 5 problems for the time. So I've written out the time. Make sure that your worksheet has these corrections. The first copy of it needed to be edited. So it has time, and then also has our HO, not our HS. So there's a few corrections. Make sure you have the most up-to-date one. But let's get started. Okay, so to figure out our latitude by LAN, we need 2 things. We need our declination, and we need our zenith distance. So in order to figure out declination, we need to find that in the almanac. So we have to go to the almanac using GMT. So we have our zone time of 12:19:18. Our zone description was +8. Our GMT time is 20:19:18. So now we can go to the almanac to see what our declination will be. On May 23rd, our GMT time was 2019. So for 20, our declination is 20 degrees north, 46.9. We're going to be increasing, excuse me. We're going to be increasing, adding by 0.5. I'm going to write here 0.5. We're adding. Our declination was north, 20 degrees, 46.9. So then we go to the minutes and seconds for our 19. We were at 19 minutes. So our little d was 0.5. So our correction is 0.2. We're going to be adding that 0.2. So we have a declination of 20 degrees, 47.1 minutes north. Then for our zenith distance, okay, so to find zenith distance is the distance from zenith to the body in relationship to the celestial horizon. So we can figure that out by saying 90 minus our HO, what our altitude is, will give us our zenith distance, what it is from the body to the zenith. So we can do, our HO was 6256.8. So that gives us a zenith distance of 2703.2. And now we need to figure out, we have our two items, declination and zenith distance. Now, do we add or subtract them to get latitude by LAN? So I draw the picture. This is the equator. I am, give or take, my DR was 47 degrees north. So that's from the equator to me, give or take 47. Declination is going to be 20 degrees north. So the sun will probably be right there. So if the sun, here's declination, here is latitude, from body to sun is going to be the zenith distance. So in order to find latitude, I would have zenith distance plus declination to give me latitude. So our zenith distance was 2703.2. Our declination was 2047.1. We add these up, we get 47 degrees, 50.3 minutes north, which is pretty close to our DR latitude. So we can use this guy as an LOP. And that's how we do number 6. Okay, number 7. The two things we need to figure out our latitude by LAN are declination and zenith distance. So for declination, we use the almanac and go into it with our GMT time. So we have zone time plus our zone description gives us GMT. So on our zone time was 12:23:02. Our zone description was -8. So our GMT time is 04:23:02 on the 21st. So on the 21st at 04, our latitude, our declination is 23 degrees north, 26.2, and it is the same throughout, so there is no difference. So we have north, and then our zenith distance is going to be 90 minus the altitude. That's our HO. Gives us zenith distance. So we have 8960 minus 3449.2, and that gives us a zenith distance of 55 degrees, 10.8. Now the next step, because we have our two items, is to figure out if we are adding or subtracting. There's the equator. So my DR says I'm in the southern hemisphere. So I know I'm somewhere down here. The sun is almost at its peak up there at in the northern hemisphere. So from me, or from the equator to me, is going to be my latitude. From the equator to the body is declination. From the body to me is going to be zenith distance. So to put this so I can figure out what latitude is, I'm going to have zenith distance minus declination is going to equal my latitude. So my zenith distance was 55 degrees, 10.8. My declination was 23 degrees, 26.2. I can do the subtraction here, and I get 31 degrees, 44.6. And I am in the southern hemisphere. So this is my latitude by LAN. And that's number 7. Okay, number 8. We are on December 3rd. We have our DR. Our LAN was at 1219, and we have our altitude of the sun when it was at LAN. So the two things we need for latitude by LAN are declination and our zenith distance. For declination, we go into the nautical almanac. So we need to convert our time, our local time, into GMT. So zone time, zone description. Seven. Okay, so December 3rd at 1919. So at 1900, our declination is going to be south, 22 degrees, 14.2, and that's going to be increasing by 0.3. 0.3 increasing, and we had 22 degrees, 14.2 minutes south. So our 0.3, we go to the 19 on our increments and corrections page. 0.3, we have 0.1. 0.1, we are increasing. So we have 22 degrees, 14.3 minutes south as our declination. Our zenith distance is going to be 90 minus our altitude, which is HO, to give us zenith distance. So we have 8960 minus our HO of 4728.9. So we have a zenith distance here of 42 degrees, 31.1. Now we have our two elements to figure out what our LAN is. So we'll draw a picture out. There's the equator. So the sun is going to be in the southern hemisphere. We are in the northern hemisphere. So from the equator to the sun is declination. From the equator to ourselves is latitude. From ourselves to the celestial body is our zenith distance. And we want to find L. We want to find the latitude. So to put that in a formula, we have zenith distance minus declination gives us latitude. So our zenith distance was 42 degrees, 31.1. Declination was 22, 14.3. So our latitude is 20, 16.8 north. And that is our LAN. Okay, so for number 9, we are given July 4th, a 12 o'clock DR, and our altitude, which should be HO. So I need to correct that again. Okay, so our first step is to figure out when LAN will occur. So we need to see when it will occur at our central meridian and when meridian passage is. So we go to July 4th, meridian passage is going to be 12:05. And our central meridian for 4 plus 4 is going to be 060 degrees west. That's 15 times 4. So if here's 60 degrees west, I am at 057, 30. So it is going to pass me before it passes the central meridian. So we need to figure out by how much. What's our DLO? So we have our DLO of 2 degrees. No. Yeah. 2 degrees and 30 minutes. So we need to convert this arc to time. We use the arc to time scale. So we have 2 degrees is 8 minutes. And the 30 is going to be 2 minutes. So we have a time difference of 10 minutes. So if it passes the central meridian at 12:05, it's going to pass our meridian at 11:55. So now we have a time, and we can get the two things we need? We need declination and zenith distance. So for declination, we need our time to be in GMT, so we could look it up in the Nautical Almanac. So we have zone time, zone description, gives us a GMT, 11:55, zone description plus 4, 15:55, declination, our declination at on July 4th at 1500 is going to be 22 degrees 47.6 north. And we are decreasing by 0.2. So I go to the minutes and seconds and find 55. 0.2 is going to give me 0.2. So I have a declination of 22 degrees 47.4 north. Now for my zenith distance, I have 90 minus my altitude to give me zenith distance. So 80, 89, 60. My altitude was 79, 56.8. So that gives me a zenith distance of 3.2, 10 degrees. So now, do we add or subtract our declination and our zenith distance? I know the sun is about 22 degrees north, and my DR tells me I'm about 12 north. I'm going to put myself right about here, lower than my sun. So from me to the equator is latitude. From the equator to the body is declination. From the body to me is our zenith distance. So to put this in terms where we can figure out what latitude is, we have declination minus my zenith distance gives me latitude. The declination was 2247.4. Zenith distance was 1003.2. I can subtract these to get 44.2 and 12. So I have a latitude of 12 degrees 44.2. Okay, so for the next part of the homework, we're going to be talking about Polaris and practicing latitude by Polaris. I'm going to do it on the answer sheets because we already have the site reduction form here. So let's get started on that. So I have my zone time was 18:13:24, and I had a zone description of +6. So that gives me a GMT time of 24 or 0:13:24, and that's going to be on April 6th. So that's going to be the 6th, not the 5th. So I can go and find the GHA of Aries for the top of the hour. So for April 6th, GHA of Aries at the top of the hour is 194.44. Then I need to do minutes and seconds. So for 13:24, that was my time. So 13 minutes, 24 seconds under Aries, I get 3 minutes and 3 degrees, 21.6 minutes. Now I can add these up. And I have a GHA of 198.06. I'll apply my longitude here. And that's going to be west, so I'm going to be subtracting. And I get an LHA of 103.54 minutes. My DR latitude was 28 degrees 48 north. And now I can start working with my altitude. So my HS was 29 degrees 01.5. That's my raw sextant altitude. My index error was 15.2 off, so I need to put it on. And then my dip was 45 feet. So I can go over and find my dip of 45 feet is going to give me minus 6.5 in between the 44 and 45. So minus 6.5. And then I get my apparent altitude. So let's add these up. Gives me 29 degrees 10.2 minutes as my apparent altitude. Now I'm going to apply my my A2 correction, which is going to be 29 degrees. So we have minus 1.7. Gives me our HO of 29 degrees 08.5. Now I could go to my special latitude by Polaris table in the back of the almanac. So our Polaris table we are going in with an LHA of Aries. Our LHA of Aries was 103.54. So we're going to go under 100 to 109. So we're going to be in this column the entire time. Now, I was at 103.54, so I'm pretty close to the 4 degrees. So I'm just going to go with the 4. Right, 103.54, yes. So I'm going to go with the 4 at 0 degrees, 39.3 minutes. And that is my A0 correction. So my A0 was 0 degrees, 39.3. My A1, still working the same column. My A1 was my latitude. So my DR latitude was 28 degrees. So just about 30. We're rounding here. So I'm going to say my A1 is going to be 0.5, 0.5. Same column we're still working in. By the month for A2, and this was taken in April. So we find April all the way across. Our correction is 0.9. And we always minus 1 degree. And then we are going to add the rest of them. (28 degrees, 49.2 is our latitude by Polaris. Pretty close to our DR. And that was our site reduction for number 10. Okay, so for number 11, we have our time, our zone description, and our observation. So in order to find our GHA of Aries, we have to be in GMT. So we have zone time, was 06:03:44. Zone description was 0. So our GMT date and time 06:03:44 on the 21st. So now we could go into the almanac on March 21st and find our 06. So we're looking for GHA of Aries at 06 on the 21st. We get 269, 12.9. Then for our minutes and seconds, we go to the back of the almanac, and we are at 03:44. So 03 down to 44 under Aries is going to give me a correction of 0 degrees, 56.2 minutes. So 0 degrees, 56.2 minutes. So I have a GHA of 270.09.1. I have a longitude, so I'm going to go with my DR longitude of 4 degrees, 54.2. So I'm going to subtract 9. Gives me So I have an LHA of 265, 14.9. My DR latitude was 49, 24 north. My sextant, so now I can start correcting for my altitude. So my raw sextant altitude was 4905.6. My index error was 5.9 on, so you have to take it off. Our dip was 12 feet. So we find our dip of 12 feet is going to give us a correction of minus 3.4. You have to figure out what our apparent altitude is. Gives us a negative number, so we have to add 60 to it. We get 48 degrees, 56.3. Our corrected for refraction, or A2 correction, goes in at 48 degrees, 48.56. So that's going to be minus 0.8. Gives us our HO of 48 degrees, 55.5. And now we need to apply our corrections from the table in the back. So our LHA of Aries was 265. So we're going to find 265 is on this page. So we're at 260 to 269. Our LHA of Aries was 265.14. So I'm going to find the 265, and I get 1 degree, 28.5 minutes. So I have 1 degree, 28.5. Staying in the same column for A1, our latitude was about 49 degrees north, so I'm going to say approximately 50. Our correction would be 0.6. A2, this was taken in March. So we find March, our correction would be 0.4. We always minus 1 degree and add the rest. So we had our 55.5 plus 28.5 plus 0.6 plus 0.4 gives us 85 minus 60 gives us 25. Carrying the 1. So we are added a 1, and then we're subtracting a 1, then we're adding a 1. So we are left with 49 degrees, 21 minutes north as our correction. This is 25. So we are left with 49 degrees, 25 minutes north for our latitude by Polaris. To number 12. Okay, so for number 17, we need to go in with our GHA of Aries. We need GMT to get there. So our zone time was 18, 17, 30. Zone description was +8. So our GMT would be 02 the next day. So that is on July 16th as my GMT. So 02, 17, 30 on the 16th. go into the almanac under July 16th at 02. I get a GHA of 324.22.3. So we'll write that in there. Our minutes and seconds are 1730. So we'll go to the back. 17 minutes, 30 seconds for Aries is going to give us 4 degrees, 23.2 as our minutes and seconds correction. Add those up. And we're going to apply our DR longitude, which is east, so we're going to be adding it. Gives us an LHA of 093, 15.5 minutes. Our DR latitude was 32 degrees, 29 minutes north. Before we get into our correction tables in the back, we need to apply our altitude corrections. So our raw section altitude was 32 degrees, 51. Our index error was 0.4 on, so we need to take it off. Our dip was 28 feet. So we find 28 feet is going to be a correction of 5.1. Apply these corrections, and we get 51 minus 4 minus 1 gives us 32 degrees, 45.5. Our apparent altitude correction for refraction was 32.45. So 32 is going to be in between our 31 and 33. So our correction is 1.5. Okay, so now we have our HO, and we can apply our A0, A1, and A2 corrections from the Polaris table in the back of the book. Our LHA that we are entering it with was 09315. Keep this here. Okay, so 093, we're going to be in our 090 to 099. 093 is going to give us a correction of 0 degrees, 33.2. For A0. Following the same column for A1, our latitude was about 32 degrees, so we'll go with 30 and 0.5. Then for A2, the month that we are in is July, so another 0.5. Now we can apply these corrections. Plus, we're adding all of these. Gives us 78.2, subtract 60, gives us 18.2. Carrying the 1, those ones cancel, so we get 32 degrees, 18.2 minutes as our latitude, which we're pretty close to our DR. So we call that pretty good. All right. Okay, so for number 13, we have another latitude by Polaris. We are going to be going in, first thing is to find GHA of Aries. In order to do that, we need GMT. So our zone time was 060727. Zone description was +10. GMT was 060727. Put that in. Excuse me, 16. 160727, and that is on the 18th. So we go to October 18th in the almanac. Under GHA, we're looking for 16. So we get 267.35.9. For minutes and seconds, we're at 727. So we go back to minutes and seconds, and we're at 727. Under Aries, so that's going to give us a correction of 1 degree, 52.1. Now we could add up that to get our GHA of Aries. We have a GHA of 269.28 minutes. We're going to apply our longitude of 154.06, and we're subtracting for our west. So we get 22 minutes and 269 minus 4 gives me 115 degrees. So now we have our LHA of Aries. Our DR latitude was 1845. Our next step is to calculate HS to HO. So from our given, we have our raw section altitude of 1850. Our IE was 5.2 off, so we added, put it back on. Our dip was 9 feet. So we go into our correction to find a dip correction of 2.9. 9.0 feet somewhere in here, so dip correction 2.9 minus 2.9 we have 50 plus 5.2 minus 2.9 gives us 18 degrees, 52.3. So now we use that HA to correct for refraction with our A2. We are 1852. So 1852 is going to be this 18 and 19. We get a correction of 2.8. 18 degrees, 49.5 is our HO that we can go into the Polaris table to get our correction. So our LHA of Aries was 155. So we're going to be in between 100, 110, and 119. So our 115 is going to be right about here. 0 degrees, 46.1. So I have 0 degrees, 46.1 as my A0 correction. Following the same column for our latitude was right at 1845, so we're going to round that to 20, and I'm going to call that 0.4. This was 46.1. 0 degrees. Our A2 correction, we are in the month of October. So we have a correction of 0.3. I don't think you saw on my 20 degrees north was our 0.4. And then for October, we're at 0.3. We apply our corrections. We had 49.5 plus 46.1 plus 0.4 plus 0.3 gives us 36.3 with a carried 1. Those cancel out, and we're left with 18 degrees, 36.3 minutes north. So pretty close to our DR. And that is how we do our latitude by Polaris. Okay. So, practicing sunrise and sunset. Let's get this on the page here. What is our evening civil twilight on September 1st? And we have a DR. So we'll go to September 1st, excuse me. Okay, so we have September. There we go. Okay, so we can see both of these. Okay. So on September 1st, so all of these sunset sunrise times are for August 31st, September 1st, and September 2nd for all 3 days. The top half here is the AM, so your sunrise. Your bottom half is going to be your sunsets, your PM's times. So we're in the top half, and I want to find what time my civil twilight is. So I'm going to be doing civil twilight for my latitude of about 33:15. So if I have 30, I'm going to be at about 5:13. But I'm going to put this in kind of that form of my interpolation table, or my sandwich table, if you will. So
sunrise or sunset?
civil twilight. I didn't even write it. Oh, the evening. I said evening.
Yep.
That would be in the PM. You are right. PM. Let me get the computer here. Okay. So we are in the PM, civil twilight. Let's see. You can see my page now. Okay. There it is. So at 30 degrees north, my civil twilight is 1846. And then at 35, it's 1852. So I'm going to write 35 degrees north, it was 1852. And at 30 degrees north, it was 1846. I am at 33:15. What is my time? So you don't have to format it like this. I know a lot of people just look at the time and then go to the table in their head, but I don't like to do things in my head, so I put it in this little format. But you might not see it like this in like a book that you're gonna, if you look it up in Bowditch or Dutton's or anything like that. It's a brief special. Okay, so if I go to my latitude table page, maybe I'll put it like this. There we go. Have my times. So my tabular interval is going to be how this changed. So that's going to be my 5 degrees. And then my difference between times for consecutive, my difference between my lower latitude. Now that says, okay, right here, the latitude, which is less than the true latitude. So you always go to the lower one, meaning closer to the equator. So even if you're in the southern hemisphere, you do the one less than. So we have 3 degrees 15. So we go in with 3 degrees 15. We're going to be on this line. And then our difference between times for consecutive latitudes, we have 52 minus 46 gives us 6. So that's going to be closest to the 5. We're going to use the 3. So if this is 46 and I have a 3-minute difference, and that's 52, I'm going to be adding it. So I have 1849 as my central meridian civil twilight time. This is 49. So now I do the same thing that I was doing for LAN with my time. I have my central meridian was 8 times 15 is, was that 120? 120. 120 degrees west. So if I have 120, that puts me at 120 and 119. So I'm going to draw it over here. There's 120. 119.32 is going to be on this side. So if at 120 it was 1849, at 119 it's going to happen before that. But by how much? I need to get my DLO. So DLO, I have 120 minus 119.32 gives me 28 minutes, right? 28 minutes. So now I need to do arc to time. What is my time difference for 28 minutes? I have 152. So I guess I'll write that 152. I'm going to call it 2 minutes. Actually, can I estimate it on here? Yeah, I did. Okay, so I'm going to say my 2 minutes. If it is passing this point at 10:49, it's going to pass me 2 minutes earlier. So it's going to pass me at 18:47. So that is going to be my evening civil twilight. So we correct for latitude and then we correct for longitude from that civil twilight that's on the daily pages. Okay, let's do one more here. Sunrise on June 23rd. So we have June 23rd. Our sunrise is going to be in the top half here. And we're doing solid sunrise, it says. We have a DR latitude of 1230, and then we have 93. So we are in a pretty low latitude. We have 10, and then we have a 20. So I'm going to write in 20 is a sunrise of 0522, and 10 is a sunrise of 0541. So that's kind of my brackets here. And I'm looking for 1230. So I go to my table. Look at me going back and forth here. So on my tabular interval, that would be this one, it's now 10. My interval is actually going to be 2 degrees 30 minutes. So I go in here at 2:30. Oops. Tabular interval. So I'm going to be on this line. And then my time difference, I have 5:22 and 5:41. So 41 minus 22 is 19. So that gives me pretty close to the 20 minutes. So my time difference is going to be 5. So I use the 20 minute because I have 19 minutes between my two times. And I came in at 10:30 because that's what my tabular interval was on my latitude. So I go in at my 20 minutes and I get correction of 5. So again, that goes from here at 5 minutes. So if this is 41 and this is 22, I'm going to be subtracting. So your 41 minus 5 gives me 05:36 as my central meridian time. But I am not at my central meridian. So this was 5 minutes. Goes right there. So my central meridian, 6 times 15 gives me, what's 6 times 15? 90. So my central meridian is 090 degrees west. So I'm going to draw this out. 090 degrees west, and I am 093. I'm over here. So my DLO is going to be the difference between those two at, so my DLO is 3 degrees 40.5 minutes. I need to do arc to time. Three degrees gives me 12 minutes. So I'm gonna have 12. And then my 40.5 gives me 2:42. 2 minutes, 42 seconds. So I have a time difference of 14:42. Now we had this as our central meridian. So at 090, my sunrise was at 5:36. So at my meridian, it's going to happen later than that. So it's going to be my, what are we going to round that to? I'm going to go with the lower number. So a little bit earlier. I like being earlier than later. So I'm going to go with 14 minutes. So I'm going to be adding that 14. And I get 36 plus 14 gives me 05:50. That is my sunrise.
So you went earlier instead of rounding off.
Yes, so technically it would be 50:42, right? But
Yeah.
I'm usually getting a time to prep myself to shoot the sun or shoot the stars or something.
Okay.
And I don't want to miss it. So I just go to the earlier time
Okay.
so that I'm out there with a little time to spare rather than missing it. Which is only like 1 minute. You should be out there maybe 5 minutes before that anyway.
Right.
Right?
So I don't know if the Coast Guard has these kind of questions or problems, but
Yes,
well,
if you were doing Coast Guard, the answer would be 0551.
okay. Oh, okay.
Coast Guard, it's going to round to the nearest.
Round up. Okay, great.
Yeah. Okay. So we're about 5 minutes left here. We got a few people left in class. So next week we are going to be doing, so this was kind of our new information. Next week I'm going to add in a little new information too. We are going to be prepping for our labs, for our peer shooting. So if you have it, you don't have to have it, it's online and on the Google Classroom. But if you have a 249, the Selected Stars Almanac. So on this one, just gonna open it up here. It gives you for certain LHA and latitude, it will give you good stars to shoot. I'm going to show you how to use this and how to prep for our labs. And then if you don't have this pub, the other, I just had it out. Where is it? Oh, hold on. The other way to predict what you are doing is using the a star finder. So that, and you can get both of these on Amazon, but it is a star finder. So we're going to go over how to use both of these next class. So if you have one, have it available so you can mess around with it. Next week's homework assignment is really just prepping for the labs. So it'll be on whatever day you guys are going to come. So everyone's going to kind of be different, or one or the other is kind of two options. But yeah, that's what we're going to do next week. And I'll show you everything how I prepare myself. And then next weekend, we're going to go shoot the sun. So yeah, any questions so far? You guys doing all right?
Mm-hmm.
All right. Well, I'll be around this weekend doing a coastal nav class on Saturday. So yeah, let me know if you guys have any questions about anything, and I will get these videos posted as soon as I can.
Okay.
And tonight I'm going to upload the corrected homework assignment. So that will be on there tonight.
Okay.
All
Great.
right.
Thank you.
Thanks, Bree.
Have a good one.
All right, good night.
Okay, so for our last one, number 16, we are trying to find the sunset on July 11th. We have a 2100 DR, and our zone description is +9. So let's see on our daily pages, no matter what longitude you're at, for our latitude. So let's correct for latitude first. So we are looking for sunset. That's going to be on the bottom half. On all 3 days, July 11th, 12th, and 13th. Our latitude is 58 degrees north, so we're going to 36. So we're going to be in between, we're going to be in between the 58 and the 60. So I'm going to write those out as 60. My sunset was 21:11, and at 58, my sunset was at 20:54. So that is my times for my latitude. Now my latitude that I'm at is 58 degrees 36. So in order to use the table in the back, I want to know what the time differences between all of these are. So here we have 2 degrees. Here we have 17 minutes. And here we have 36 minutes. So if we use this information, go to our table, we have a tabular interval of 2. So we're in the 2 column. And then we have 0 degrees 36 is our interval between the 58 and the 58, our actual latitude. So we're in this column, and then we have 17 minutes as our difference between time for consecutive latitudes. So we are right in between the 15 and the 20. So I might call it, that's 4, I might just call it 5 minutes. So we'll call this 5, and we would be adding, so that would make our sunset 20:59. And now we need to correct for longitude. So this is going to happen, our sunset is going to happen at 20:59 on the central meridian. So what is the central meridian? Is going to be with a 10, it's going to be 150 degrees west. So if I'm at 157, I am going to be over here at 157.21. So what is my DLO? My DLO between these two, I have, do it over here, 157. It's 7 degrees 21 minutes. So now I need to convert that arc to time using the back. Arc to time, our 7 degrees is going to be 28. And then our, 28. Our minutes are 21, so we're 21 even with 124. So our total time difference is going to be 29:24. So if our sunset happened on our central meridian at 20:59, and we have a 29:24 second time difference, it's going to happen later. So I'm going to round, and I'm going to say 20:59 plus 29 gives me 21:28. So it would happen at us at 21:28, and that would be our time of sunset. And that's it for our time calculations.